Unit 4 we have started, and I'm going to discuss about differential equation. And let me discuss it here. Okay, that basic definition of differential equation is very important. We understand what are independent parameters, what are dependent parameters when we look into this. Okay, so the idea today is to talk about differential equations. I'm going to give more examples and we are going to understand it better. Okay, let me just write down. Okay, so basically when you write down an equation, okay, and it will basically contain independent and dependent parameters. We're going to take an example and we're going to see this, which contains derivative of one or more independent variables, okay, with respect to one or more dependent variable. Okay, one or more dependent variable is called. So if you give a definition of differential equation, this will be something which is important. Okay, it's a differential equation. So we have got a derivative of independent variable with respect to the independent variable. Okay, so if we just take it this way, okay, let me just write down an expression and let me tell you how we read this. Okay, so if I just write it down in this way, let me say I write down a differential equation here. Okay, let's say I write it down as dy dx, okay, is equal to, or maybe minus of, let's say minus of 2a divided by y is equal to 0. Okay, so this, all of you know that this is actually a first order differential equation, first order differential equation, right? Something a first order differential equation, and here we actually basically going to have the dependent and the independent variable. So y will be a function of x. Okay, so y will actually depend on x, so this is dependent. Okay, and x will be independent. So once I write down this expression, I think this will be more clear to all of us. X is obviously independent, because you can actually have an expression of let's say y square is equal to 4ax. So in general, when we write down such expression, we know whatever is on this side is actually independent and whatever is on that side is actually dependent. Okay, so what we do here is we're just going to check it out now. Okay, let's check this. An equation which contains derivative of one or more independent variable. So we see that this is actually a derivative of a dependent variable. So that means, I've just written this to make it clear. Okay, so you see it will be derivative of one or more dependent variable. So y is dependent, we are taking a derivative of that with respect to one or more, this will be independent. Okay, so as I write down the expression, the definition becomes clear. Okay, independent variable is called differential equation. Okay, so this is called actually differential equation. There is also something which is actually called the ordinary differential equation. Okay, so a differential equation which will contain ordinary derivative of one or more dependent variable. It will be one or more dependent variable, not a problem, but with respect to only one independent variable. So there will be only one independent variable. So this example is also an example of ordinary differential equation. Sometimes y may not be a function of only x, it might be a function of t, it might be a function of z, and so on. So when you have the differential equation, it's a mix of different independent variables. Okay, but here we are saying that it is a variable only of one independent variable. So this is our differential equation, no doubt, but at the same time this is also a very good example of a ordinary differential equation. So that's actually the two things that we should usually remember. Okay, so usually whenever we write down such expression, our aim is to actually find out solution of the differential equation. Okay, so whenever I have such expressions, okay, let's say y square is equal to 4ax, this is actually the solution of differential equation, right? This is something which we already know. This is actually the solution. So maybe you are given a differential equation like this, and you are asked to solve it, and you solve it and you see that the solution is y squared is equal to 4ax. If you are integrating and all, you'll get some differential constants and all, and then you use boundary conditions to actually find out the answers. Okay, so let's try solving it. Okay, so I'm just taking this an example. I'm not asking you to solve it, because when I explain, I have to explain it in detail. That's very important. So what I'm going to do is I'm going to solve this. So let's say I'll take that example only. We already know what is the solution. Okay, but we are just revising here, just refreshing. 2a divided by y is equal to 0. So if you really want to solve such expression, okay, there are a lot of techniques, and one of the most prominent technique is actually separation of variables, if you remember. So as I said, always make a list of techniques. Here the technique that we are going to use is separation of variable. Okay, so in separation of variable, what we do, we actually separate out the the variables here. So y and x are the variables. So y dx, okay, plus, or maybe I can just write it down in more general form. Fy dy plus, okay, fx dx is equal to 0. So I have to basically just separate out first. Before I really integrate it, I have to actually separate that out, right? So I'll just take this to be fy dy. So that's the first thing that we do in separation of variable. Sometimes it becomes difficult, so we have different techniques for that, right? So if you look into this expression, okay, it's a function of y and x, okay, so we can actually try separating out the variables here, right? So you see, when I try to play around with this, dy by dx is equal to 2a divided by y. So I'll separate it out. I'll take the cross multiplication. This will be y dy is equal to 2a dx. So I've separated it out. Okay, so I can simply integrate this. So I can just simply write it down as integration of y dy, take 2a dx on the other side, so it will be minus of integration of 2a dx. This is equal to 0. So when you basically solve it, this is y square divided by 2 minus 2ax is equal to 0. Okay, and since we are integrating it, okay, and we don't have any boundary condition as such, so I'll just put the limit as c. I think that is okay. So you can just cross multiply this, you get y square is equal to, cross multiply LCM and all, it take 4ax plus 2c. So if you have boundary condition, you can get the value of c, else you're getting a solution for this expression. So this is your differential equation. What differential equation? Ordinary differential equation, and you solve it by separation of variable. So in a similar way, you get different kinds of differential equation, and there are different ways of solving it. Okay, so some more things that we need to revise on differential equation, okay, which I just like to do it. Okay, anyway, so everything is about revising differential equation today, because this entire unit will actually, you'll see a lot of differential equation, and these things are important in physics, because when you do quantum, classical and all, sometimes you need this. Okay, so we have got order. So we have got something which is called order of differential equation, and something which is called degree of differential equation. Okay, so when we say order, this is actually the highest derivative. Okay, highest derivative, let's say differential equation. DIFF means differential, okay, not difference. Please make it clear. Okay, so if I just write down, let's say I'll take an expression here, maybe d4x dy square dy4, sorry, plus maybe d x by dy to the power 4 or 3 or 2 maybe is equal to 0. Okay, so in this particular case, if someone asks me what's the order, okay, order would be 4, because it's the highest derivative differential equation. It's not the power of the derivative, It's how many times we are taking the derivative. So we're taking it 4 times. So that's why the order is 4. It's not 2. So when I ask you, the simple questions, even in entrance exams also they're asking these questions, which you might have studied even in your undergraduation. Okay, so it's expected that you know it. So that's your order. Okay. On the other hand, if you take degree, okay, so maybe I can write down an expression example and then I will explain it better. So maybe I can take ds by dt to the power 4 plus 3 times of s, okay, t to s dt square. So this 2 which is written is your order, which is equal to 2, and this is actually 1. Okay, the power of this is 1. Okay, and this power is actually called the degree. So whatever is the highest order, whatever is the power of that highest order will be actually your degree. Okay, so that's the difference between order and degree. Okay, so try to recall this or remember this. Order is very easy, degree sometimes we get confused. Okay, so you have to see which one has got the highest degree order, and what is the power of that particular order. That will give you the degree. This is one more thing that we should know. Okay, and there are a lot of techniques, okay, to solve the differential equation. One I think we have already discussed. Let me take an example, another example here. So one is let me write it first. Separation of variable, one of the most popular techniques. Okay, and sometimes it becomes very difficult to separate the variables. Okay, so then what we do is reduction. Okay, so there what we will do is another technique that you should remember. You will get only these two types, okay, mostly whenever you want to solve. So just be sure that what kind of problem you are having, and based on that you use the technique. Okay, so reducible to variable separation method, okay, or separable method maybe. If it's not, we'll reduce it into that form. If it's already in the variable separation method possible, we'll directly separate it out, right? So this one we already know. Let me just write down this comparative so that we remember this. Fx dx is equal to 0. So whenever you actually get any expression, you are supposed to just separate it out, right? So it will be x square plus 1 dy plus 1 plus y square dx. So you get such problems, an example, okay, and you want to find out the solution, you have to use separation of variables. Okay, on the other hand, if we just look into the reduction method, okay, we can have different kinds of problems. For example, let's say uh, x plus y whole square dy dx is equal to 1. Let's say this is an example. Okay, here what is the problem? The problem is I have got x plus y whole square. So that means if I expand it, this will be 2xy dy dx. So x and y are together. How do I separate them out? That means I have to use the reducible to separation variable method. Okay, so this may be one example. Okay, let me show you some more example. Maybe I can take a sine and a cos function, maybe something like this. Dy dx is equal to sine of, and this is x plus y plus cos of x plus y. Okay, this can be another example, and so on. So you'll have these kind of questions, okay, where you cannot really use the separation of variable idea, because problem is x and y will appear together. Okay, so there what we do is we actually do some kind of substitution so that we can actually reduce it to a separation of variable. So this is very simple. Okay, so what you do is you take x minus y. I'll take an example now. Let's solve it. Let's say x minus y whole square dy dx is equal to 1, or I can take x plus y also. I think it's the same thing. ठीक है, so यहाँ पे हम लोग क्या करेंगे, we'll just take up let x minus y is equal to t. Okay, is equal to t here. Okay, so what you will do is you need dy dx. So you can take d dx of x, which is 1, d dx of y is nothing y dy dx, and d dx of t is dt dx. अब मुझे चाहिए क्या, मुझे चाहिए dy dx, I need dy dx, so I'll just take dy dx, dy dx. See, being a student of masters, it's not that you should only know the technique, you should also identify the technique straight away. Looking into the question, you should be able to tell which technique should I use to do it. Okay, randomly someone might tell, okay, I can simply separate it out and do it. That's fine. Okay, you can get your answers and all, but it's preferable that you just make sure that you know the technique. That's very important. ठीक है. So x minus y का क्या हो गया, t square हो गया, so this is t square, and dy dx का हो गया 1 minus dt dx, okay, is equal to 1. Okay, so task now, solve it and tell me. ये वाला solve कर लो, ये वाला तो I think you can do it. Tell me what is the answer to this. And this one I have told you what to do. You just substitute and get this expression, and then you have it, solve. This you can solve. So you see, you've reduced it to a separation method because t squared is separate, and then it is t squared dt dx. Okay, dx you can take it on one side and try doing it. Okay. So try to solve. Okay, you can take the LCM here. Okay, and then you can t square on one side, everything else on the other side. Cross multiply, get it. That's it, right? So कर लेते हैं इसको, I guess. So it will be what dt dx, if I take dt dx is equal to what? So it will be 1 by t square, and this one will go on the other side, or 1 minus 1 by t square, right? 1 minus 1 by t square. So if we take it, it will be 1 minus t square divided by t square. Okay, hopefully I did it correct. ये सेट चला गया, ये सेट आ गया, so ये t square minus हो गया, right? 1 by t square. Yeah, it's correct. ठीक. So this will be there. So cross multiply, ये dt इधर ले लो. So t square divided by 1 by t square into dt is equal to dx. Then you integrate it, find out the answer. Okay. So solve these two. Okay. So we will end today's class after you find out the solution. Okay. And tell me the answer.
Sir, first one equal to tan.
Integration. You will forget this 100%. So tan inverse x, integration of 1 by x square plus x square. Okay. So you have to remember this result. That's it, and that's how you do it, right? इसको इस साइड ले लो, ये माइनस हो जाएगा, and take dx by 1 plus x square. This will be dy by 1 plus y square. You should get it. Just the division. Okay, that's it. पहले second वाला solve करो. First वाला I think it's a cake walk.